massage. I take 5 points extra credit for every squeeze. Like,
Alright.
don't worry, I won't follow.
Take out 5 points.
Yeah. Makes it worse. Take off 10.
Okay, we're good.
Alright. So those are the two things that you understand. Why e to the x? Well, we talked about e is roughly 2.7, 2.7128 roughly, something like that. Okay, so, but we just know it's 2.7. So the graph's gonna be like this. Has a e to the 0 is what? 1, right? So the graph's gonna be something like this. Basically, there's a point right here, and there is an asymptote right here. So why is that asymptote important? Well, first of all, e to the 0 is 1. E to the 1 is e. Those are the basics. So e to the 1, this is going to be e here. So those are the 2 points that it's going to has to establish. Now, what we're going to do is we're going to talk about the natural log graph. But this one is also something else. Limit as x approach negative infinity of e to the x. Well, what will happen when they approach negative infinity? You have to know this. Huh? Ivy? That's 0, because it's approaching what? The y value is approaching what? 0, right? So this one's very important for you to understand. When they go to negative infinity, it's going to go to 0.
Why?
So another graph you need to understand is this one. So is this one here. They are inverse to this, so the graphs should be like something like this. But this is the point that it's going to go through. So here is going to be 1, 0, which is natural log of 1 is equal to 0. You have to know that. Natural log of 1 is 0.
Is it like a law?
Huh?
Is this like a law thing?
But okay, we're gonna talk about why natural log of 1. Just memorize now. We're gonna talk about this. Okay? Natural log of e is equal to 1. You have to know those. So those are information that you have to know. And also limit x approach to 0 from the positive sign of natural log of x is going to negative infinity. It's going down to negative infinity. Okay, so you have to understand that. Now what else do you have to understand? Because yesterday we talked about why is natural log 1 is equal to 0. We talked about natural log is equal to log base e, right? So what is log of e? Well, we're gonna say assume that's equal to some type of value. Okay. Log e of 1. So same thing as natural log of 1, right? So therefore is what? Well, we're gonna say that's x. So that means e to the what value equal to 1? Well, anything e to the 0 is equal to 1. Anything to the 0 power is 1. Look at that, e to 0 is 1. So x must be 0. So that's how you get 0 here. Does that make sense? Because that's log e of 1 is equal to x. E to the x equal to 1, x equal to 0. Well, what is natural log of e? Well, log e of e is equal to x. So e to the x is equal to what? E to the 1, so x has to be 1. So therefore, natural log of e are inverse to each other, it's gonna cancel each other out. But what's easier to notice, this is a root back end reason. There is a property here that you should know. It's called property of the base logarithms. So we're gonna talk about all this property. First one, the property is this. So yesterday we talked about all this property, but this one is also just as important of log, natural log. So we're gonna talk about start with log. So if I have a log, base of b of 1, so any base, what do you think that's equal to? So you think if you draw it hard, right? B to the which power is equal to 1?
0.
Has to be 0. Okay, so that was the first one. The second one, that's also very, very important, is log b of b. What do you think log b of b is?
1. For sure.
That's equal to 1, right?
Yes.
Log b of b. So that means b to which power is b? B to the 1 power is b. Third, log b to the b x. What do you think this one's equal to? Log b to the b of x.
So b of b to the x equals x. How'd you draw the heart again? Wait, hold on.
From the base to the exponent.
This one is inverse to each other. Or you think about the third rule yesterday. What was the third rule yesterday? The x can be in the front, right? So x of log BB, well log BB is 1, so therefore it's equal to x.
Ha! I was right.
4. Now this one's interesting. B of log of b of x is equal to what?
Wait, why'd you write so weird?
It's b to the power log b of x.
Oh.
So this has just become x again. Because b and log b, see that b log b here? They are inverse to each other. It's like square root of x is square root of x squared. That's just cancel each other. This is gonna give me x. So those on the pre-calc knowledge that you should know. So what's the natural log of 1 here? We already know natural log of 1 is 0, right? 2, natural log of e is equal to 1. 3, we already said that. Natural log of e to the x. What do you think that is? Well, we can convert natural log to what?
Log e.
Log e, right? So it'll be log e of e. So the answer is going to be what? Natural log. Oh, so e to the natural log of x. E to the natural log of x is equal to what? X. Because e log e, right? The same thing as this. E log e, except it's b. So it doesn't matter. That's just going to give me x. So those are the general property. Now, it's not memorization. Just understand what's going on. So that way you can see all the things that is being solved. Question about this?
So this is just basically the part rule.
Yeah, just all the rules. So yesterday we also talked about rule. Yesterday we also talked about product rule, right? So it'd be natural log of x plus natural log of y is equal to what?
Log of e times
Number 2, if you have natural log of x minus natural log of y is equal to what?
Log of x divided by y.
Number 3, natural log of x to the y power is y natural log of x, right? The 4 is log of b of a is equal to natural log of a over natural log of b. So those are essential things that you need, but not as much information. You're gonna see like a lot of things repetitive.
How does the fourth one work?
4-1?
No, the last one you just put. How does that work?
Changing base formulas. How does it work? Yesterday we did a question like that, right?
I don't know. You were teaching.
Yeah, yesterday we did a question like that. It was on yesterday's notes.
Yeah.
Yeah, but I didn't really prove how to work, but it's just to show you how to do a problem. I say 3 to the x.
Oh yeah, we know how to do it, but like.
3 to the x is equal to 5. So how do you find out what the x value is? So right here it's gonna be what? 3 to the 5. Wait, log 3 of 5, right? Log 3 of 5 is equal to x. And then we say the calculator doesn't do that, or newer calculator does. Or you can use the way it's just gonna be natural log of 5 over natural log of 3 is equal to x. Now, if I want to do natural log on both sides, natural log of 3 to the x equal to natural log of 5. And then x natural log of 3 equal to natural log of 5. X equal to natural log of 5 over natural log of 3, right?
And
So therefore, those two has to equal each other. Therefore, this one has to equal this. So I just go in 2 directions. First, I just do the hard. I got this. But we don't know what's log 3 of 5. So we assume that we don't know, right? We assume that we don't know this. I don't know what's log 3 of 5. But I'm going to use a different way. I'm going to do natural log on both sides. Put down the x equal to natural log of 5, natural log of 3. So therefore, those two are equal to each other.
And logs can cancel, right?
No, log cannot cancel.
Just making
Just
sure.
like today we were doing like an inverse sine function. It was like this, y equal to the sine of x, and they say switch x equal to sine y, and they say solve for y, and they say, my pre-calc student, let's divide by both sides by sine. Because y is within the function of sine.
Yes.
They call it argument, so this is, it's within the function. You cannot divide by both sides by sine. You get y equal to x over sine. This doesn't make sense. But mathematically, that's what people do. Right? Because you cannot blend them. They say 2x equal to 3, divide by both sides by 2, x equal to 3 over 2. But that wasn't a thing set. So, question about this part.
There's
Okay.
multiple ways to find it.
Yeah, there's multiple ways. Logarithm, there's so many ways. I mean, did I tell you guys there's a question like this? Log of, I don't know, 16 of,
Pretty sure we can tell the question.
x is equal to negative 3 over 4. And they say, hey, can you find out what the x is? And this is an ACT problem I tutored 2 weeks ago.
You want us to do it?
Well, you can figure out how to do that, but I'm not.
16.
That was an ACT problem I saw over the week. Can I erase this?
Yeah.
So let's talk about how to solve problems. A lot of time you're gonna have 2 cases. Let's say if I have, let's say, e to the 2x plus 1 is equal to 6, and how do I solve for this? This is in pre-calc, right? How do I solve for 2x? So how do I solve for x? I had to isolate the e first. I had to isolate the e first, right? So I'm gonna say what? What do you do? subtract 1, good. So that'd be e to the 2x is equal to 5.
Oh shit, I canceled out forward.
Okay, now how do I get how do I get 5x?
Drop the
How do I solve for x? Ln both sides, because ln and e, what happened to the property that we just say?
No, okay.
Cancel. Oh. You must do something on one side, you must do the other side, right?
Wait, how come if you do the natural log over here, that moves that to the... Oh wait, never mind.
I just did natural log, just write natural log on both sides. And what do I do?
You don't divide by natural log.
Natural log of e is going to be what? They're next to each other, right? So that's going to give you 2x is equal to ln of 5. S equal to ln of 5 over 2. And that's, now this cannot simplify. If it's ln of 6 over 2, that does not simplify. Okay? Students simplify it all the time. Oh, the ln of 6 over 2, that's ln of 3. Duh. No, it's not. 5 is within the natural log functions.
What happened to the e? Did it cancel out with the ln? Or
E and ln cancel out, yes. Do you see that? Remember that property, ln of e? As a log e of e, log e of e, they cancel out, right? So how about this one? ln of 2x minus 1 is equal to 3. How do I solve for x?
Trick question, you know. So if you took the natural log of both sides first,
You can do natural log or natural log.
you take the e of both sides first.
Yeah, but e which way? E multiply or e to the...
E to the... What, you were gonna finish saying that?
So what you're gonna do is you're gonna e to the both sides. But you have to do e is not multiply, it's to the power. Remember on the property says what? E to the natural log of x is equal to x, right? Remember that property that we had before? So then we have to do e to the both sides. Are we okay? So e and natural log cancel out. So that's going to be 2x minus 1 is equal to e to the 3. Now I can solve for x. 2x equal to e to the 3 plus 1, x equal to e to the 3 plus 1 over 2. Question about this part.
So it's cancel out natural log. Yeah. E to the eighth. ln is exponent.
You're yellow. Huh. Interesting. Let's see. Did you solve that one?
108.
No, I solved it.
It's just.
What do you mean it's just?
16.
Good job, I think.
Oh, my bad. Oh, the hard one.
So you solve this one.
Oh, you can do the hard across the equation? Okay. Yeah, what I did was this. I didn't break that, I just bent it
A few times.
in different directions. I did it.
You've been at heart.
doing that one?
Yeah. Think about all the property that you can do here. Remember, e and natural log has to be next to each other for you to cancel, okay? Actually, think of two different ways to do it. Next, showing me.
Back does hurt.
We have e to the x is equal to 1. Can x just be any
That's not what she got?
What now? Oh, I got that. Wait, you. I got the same question. I got the same answer. So what you did. Oh yeah, that's what I did. And then you. Oh, you just simplified it.
So the quicker way is think about properties, and there's more than one way to solve this problem. I'll show you two different ways to approach this problem. This problem here is equal to 1. I can get rid of natural log, right? How do I do that?
E.
Okay, so I can do this one, right? E to the natural log square root of x plus 4 is equal to e to the 1.
What do you even call it?
E and natural log cancel, right?
Yeah.
So that's square root of x plus 4 equal to e to the 1. I must square both sides. So that's going to be x plus 4 is equal to e squared. X equal to e squared minus 4. Now let's use a different way to approach this problem. Okay, so natural log of square root of x plus 4. What's a different way to approach this problem?
I do that to the 1/2 power.
1/2 power, good. So it'll be natural log of x plus 4 to the 1/2 power is equal to 1.
So you put 1/2 in the front, right?
Now I'm going to put 1/2 in the front. Now I cannot e to the both sides. Why can I e to the both sides? Because there's 1/2 in the front. But how do we get rid of 1/2?
Multiply.
Multiply by 2.
Yeah.
And you're still going to get the same track as this one, right? So it'll be x plus 4 is equal to e squared, and x equal to e squared minus 4, and you still have the same answer as here, regardless what happened.
Yeah.
Thank you.
Oh my gosh, I lost brain cells.
I'm forgetting that.
Does that make sense?
Do.
Okay, so we're going to talk about expansion and compression. That's what we're going to do in calculus. We're going to do expansion first because we do compression. No, expansion. Okay, we do expansion first. So L of let's do Ln. Ln of x squared third root of x to the 4th y z. How do I expand this?
What is expand? Mr. P tried to show me that one time, but then I
Because
I don't know how to expand, like eat more.
yeah, I saw a meme like this. is expand this, and they were like this. I saw a meme of that. I was like, oh wow, that's pretty cool.
Hey, I bet I could learn compression too then.
Compress makes me compress.
So we're gonna say x, y to the second power here. So how do I expand this? It's ln of x squared to the third root of y squared over z squared. And we say expand this as much as you can, as many natural log as possible. That does not feel right.
Is that a Z?
Yes.
Okay, so expand as much as we can. So what we're gonna do is we're gonna expand this as much as we can. How do we do that? Well, first of all, realize that the rules over there, what are the rules? The quotient rules and the product rule over at the end, oh, it's not there anymore. So I'm gonna write down here, ln of x plus ln of y is equal to ln of xy, right? So this is like equilibrium in chemistry, right? You can go this way or you can go this way, right?
Why would you go the other way?
Because the math is going both ways.
And then do it from there. Like, I would subtract first, right?
Oh, it's not.
I call the whole thing A and
That's all I have.
and from here,
That's,
this is
that's literally the whole back.
Wait, that's not a bill, right?
No, it's not.
Okay, so how do I expand this? The easier to expand, you just have to write out as many then. This is between here is multiplication, right?
Yes.
And here is division.
Yes.
So it'll be ln of x squared plus ln of y to the 2 over 3
All divided.
plus, right, minus ln of z squared.
Do you have two parentheses, the first two together?
Yeah.
You can parentheses this, yes.
Ah, I can see.
That's good, because you understand the parentheses because it will help you on the next question. So now I can expand this, it'll be 2 natural log of x plus 2 over 3 natural log of y minus 2 natural log of z. Does that make sense?
Oh, yes.
Okay, but tomorrow we're gonna take a derivative of this, so which is, but right now we don't have to take a derivative, we just need to expand this. Now if I give you this, can you compress? So this is called expansion. Your homework is gonna have expansion. We will write in as many terms as possible. There's compression. Compression is going backwards, so write in one log term, then I can say, okay, that becomes natural log of x squared plus natural log of y of 2 over 3 minus natural log of z to the square. And then it's adding, so it'd be natural log of x squared, y to the 2 over 3 over z squared. That's right in one log.
Yeah. That's when you set the value and you see how it goes.
So, we only have to do the first part.
That even happened.
You know when you have to eat and then you see how it goes. Compress.
It compresses into one log. Okay, so I'm gonna give you one here, ln, I'm gonna give you a tricky one, x squared over square root y times z to the 3. I want you to expand as much as you can, and then compress back, should get the same number, same equation. But there were some people's gonna make mistake here,
I got
and I'm gonna tell you that Brendan probably won't make a mistake on this one because he sees something that you guys didn't see before.
What? I will or I won't?
You probably won't.
Wait, I guess thought you said will or won't.
Won't.
Won't? Okay. You're correct, sir. I'll prove you wrong. Okay. So that's. That's the one I can't see. What you do. space?
Why are you doing it on a map?
That's not a map, that's a maze. It's different. There we go. Is that a multiply at the bottom?
Yeah, a dot. I
Okay.
don't know. Multiply or divide. So why do people make mistakes? Do you see why people make mistakes?
Yes. They're not as cool as me.
Nope, I did not do that.
So why do people make mistakes?
Because they forget to distribute the negative.
Alright, got it. And there's a parenthesis on the bottom. But usually people don't see that parentheses. That's why he was pointing out parentheses, that I wrote it in parentheses as a good job, because that was the key thing for you guys to see.
That's why it's called parentheses.
See, there's a parenthesis here that you don't see right here, but there was a parenthesis there. Now, if you have that, then it's gonna be ln of x squared minus ln of, I'm gonna break down slowly, so it'll be y to the 1/2 times z to the 3, right? But now, these two are multiplying together, but however, there's a negative sign in front. So it'll be ln of x squared minus parenthesis ln of y to the 1/2 plus ln of z to the 3rd. And then I have to distribute that negative sign inside. Does that make sense? Did you do it? Empress? Huh? You didn't, right? You should distribute. Now, it's going to be 2 ln of x minus ln of y to the 1/2. So 1/2 in the front. And plus 3 ln of z minus, right? This one's supposed to be minus. See, I just make the mistake. So that's why people are going to get a wrong sign when they do that.
Do we have to write out all the steps? Or can we
No,
just-
you can, I can go from this step to this step
Okay.
with no problem.
Okay, that's good for me then.
Okay, now the calculus part. The calculus is really easy.
We have like 3 minutes. And I was like, fun.
That's good, derivative is easy. So we say, hey, let's take a derivative of this. So we're going to teach you one thing only. ln of u d to the dx is equal to what? U. Get a correct notation for you?
Yeah, thank you.
So the fun part's over, part 2. We have to take the derivatives, so good luck with that.
No, derivative is easy.
That's a lie.
No, the pre-cal is harder part, I swear. Pre-cal is a harder part for you, but derivative is actually pretty easy. Okay, d to the dx to the natural log of absolute value u is gonna be u prime over u. U prime over u. Yeah. Because the u cannot be negative. If u negative, then that function doesn't exist. So it has to be positive. Remember, natural log of u, because that graph's going like this, it doesn't have a negative side. You cannot natural log of a negative number. You have a natural log of a positive number. So therefore, the function has to be end up being positive. So this is the only thing you need to know for the calculus part. Pre-calc, there's like 20 different rules, right? But for calculus, it's super easy. Then you say, okay, u prime over u. What does that mean? Well, that means this. Y equal to natural log of x squared plus x squared times by x minus 1 over x plus 2 to the square, like this. You say, let's take a derivative of this.
Yeah.
Okay, let's take a derivative of this. And you say, well, I don't know. There's a chain rule, product rule, and then there is a natural log. Holy shit. Right? It's not the problem is, actually the hard part is not calculus. Because if I know how to expand this correctly, what will happen? Let's expand this correctly before we do calculus.
Oh, okay. So.
Let's expand this to as many natural log as possible.
So the -2 natural log of x.
Let me finish this. Right? Natural log of x squared plus natural log of x plus minus 1 minus natural log of x plus 2 squared. I may expand more. So that's going to be what? Natural log of x 2, right? Plus natural log of x minus 1 minus 2 natural log of x plus 2. And you say, okay, now this is the pre-calculus part. Who left?
Oh no!
Okay, now I'm going to take a derivative. Don't worry, it's on the video. This one's u, so u prime over u. What's what derivative of x? Derivative of x is what? 1, right? Over x, right? Plus derivative of x minus 1? 1 over u. So u prime over u, so it's
Oh, natural log. You know,
Wait, what happened to the natural log?
natural log is gone. Look, derivative of natural log of u is u prime, derivative on the top, and original function on the bottom. And the 2 is going to be the function in front, that 2 is a constant. And that's going to be, derivative of x plus 2 is what?
1.
And that's it, you don't even have to simplify, just leave it like that, and you're done.
Wow.
The calculus part is super easy. The hard part is the pre-calc. Anybody want to say hi to Isha?
I got the video for you.
Thanks, Kyle. I wasn't gonna record it for you, but Kyle said.
I had to.